All right, so let's look at question C there, which is saying the current in the wire is due to electrons, each with charge Q, that move with speed V along the wire. There are N electrons per unit volume. For a wire having a cross-sectional area S, the current I is given by the equation I is equal to N by S by Q by V to the power K, where K is the constant. So by considering the homogeneity of the equation, determine the value of K. So what are we supposed to do here? Our job is to find the value of K, which has been given in this case as a power there. So we have to make sure we know the dimensions because this question is under dimension analysis. So we have to make sure we know the dimensions for all these physical quantities that we've been given in the equation there. So they've given us what? They've given us current, which is represented by I. So current is measured in amps or ampere, whatever you can call it. So current is measured in ampere, represented by that symbol A there. And we have N, which is in this case has been used to describe the electron density, the density of the electrons. So we're going uh, uh, to to express it in per cubic meters rather. So it will be per cubic meters, representing electron density. S, they've said is cross-sectional area, and we know to say area is given to meter squared. That's the SI unit for area. We have Q, which is representing charge here, and charge is given in coulombs. We also have V, of which V is one of the simplest. This is just meters per second, like that. So now that we know all the base SI units for the physical quantities that have been given in that equation, what are we going to do? Let's put that equation into its dimensions so that it becomes easier to handle. So let's do this. So we've been given this equation. They said we have I is equal to N S Q V to the power K, like that. So now that we've already seen the dimensions of all these physical quantities, let's now put them in this equation. So we're going to have A, which is representing ampere on the on the left hand side, and I have N. We said what is the value of N? It is going to be expressed in per cubic meter. So I'm going to say per cubic meter here multiplied by the value for S, of which S is just giving me the cross-sectional area, and this should be expressed in meter squared. We have Q. Q is expressed in coulombs, so I'll put a C here. Then we have velocity. Velocity is expressed in meters per second, like that. Then this velocity has a power of Q outside there. So from there, what are we going to do? Let's now simplify our equation by canceling out some units that are common. I'm sure we all know how to do that now because it's just basic physics from unit conversions. From the topic of units, I already talked about that. So we're going to have A on the left hand side will be equal to what are we remaining with? We're remaining with per meter squared can also be expressed as 1 over m power 3, but I think let me just put it the way it was, which is I'll put per meter cubic here, per cubic meter here, and I have m squared there, and I have c there. Then what about this guy, which is here? You can see to say we have m over s. So we're going to distribute the constant or the power k to both the numerator and the denominator, which by so doing, what are we going to remain with? We're going to remain with m to the power k over s to the power k, like that. Okay, so hope no one is really behind here. All right, so now after reaching this point, now what do we do? I'm sure in mathematics, I don't know what topic was that. Even in grade 10, you guys used to do that. Algebra. I think it's algebra. Algebraic expressions. You know, to say if you are multiplying two numbers expressed to certain powers, but having the same base, it is the same as you just add the two powers of that base. So we're going to have A being equal to m. When I add negative 3 plus 2 here, I'm going to remain with what? With m power minus 1, like that. From there, what am I going to remain with? I'm remaining with it, which means I've removed these guys. These two, I've dealt with them. What else am I remaining with? I'm remaining with the column. So I have a column C and D, this one, which is m to the power k multiplied by s to the power negative k there. So I'm just the negative, it's just trying to show you to say that is still maintaining its role as a denominator. Okay, so let's go to the next page. Okay, so now you can see what we're remaining with. We're remaining with mass being equal, or mass to the power minus 1 multiplied by the column, which is the C there, multiplied by m power k to s, m power k multiplied by s to the power minus k. So what are we supposed to do? They've told us to say there is homogeneity in this equation, which means this equation is already proved to be correct. It's homogeneous. All the sides are equal. So what are we going to say? What are we going to do now? We're going to say amps, the values for electric current can also be expressed in another way, which is equal to what? It is equal to coulombs, which is charge per second. This guy. So that is also another way in which you can express your your electric current, which is the ampere. So what are we going to do right now? Let's replace that guy, which is the ampere here, by coulombs per second. So what am I going to remain with? I'm going to remain with C multiplied by s to the power minus 1. This will be equal to what? Let's now put like terms together. We have m here, and what are we having? We also have another m there. I'm sure you can tell to say that is also remaining with the same bases. So what are we going to do? Let's add those two bases again. So what are we going to remain with? We're going to have m to the power k minus 1. So I've just gotten this base and that base, that power and add them together because they're having the same base. So I'm also having C here, which is still remaining. And I'm also having maintaining my S multiplied by S to the power minus K, like that. Okay. And now that we have now expressed both sides, the left and the right-hand side of our equation, we can now cancel out some things that are common. So from what I'm seeing, C here can disappear with this C there. And what are we going to remain with? We're remaining with an equation, which is now simplified. We're remaining with S to the power minus 1 because it is a denominator being equal to m to the power k minus 1 and the s multiplied by s to the power minus k. So they've told us to say there is homogeneity in this equation. So what are we going to do? We can see now to say we have two units of time on both sides of the equation. So we have this which is the s to the power minus 1, and we also have this, which is s to the power minus k. So these are the things that we are going to focus on now. Let's leave the m to the power k minus 1. Let's focus on the units that are common there. So I have s and s on both sides of the equation. So what are we going to do? Let's focus on those guys. So I'll say s to the power minus 1 is equal to what? Is equal to s to the power minus k. We get rid of the bases there, and what are we remaining with? We're remaining with the powers, and the powers are telling us to say -1 is equal to minus k, like that. And from this expression, I'm sure I've been taking math for a long time, almost the whole lot of your life. K is going to be given as what? As 1. And that is going to be our value of k. So the question was telling us to find the value of k, and that's all. That's actually the value of k. Let's move on to another question, which should be question 2a. So question 2a is saying Molenga fell off a tree and broke his leg, which was put in a cast. The leg and the cast weigh 190 newtons. Determine the weight of the other block, W2, which is this one here, and the angle alpha, which is this one, such that no force is exerted on the hip joint by the leg plus cast. Okay, so I remember we did a similar question in tutorial sheet 3 and 4. I did a lot of questions which were very, very similar to this one, but let's just go through it quickly so that we go to the next question. So question 2a, started from here. Question 2a has given us a diagram. So they've given us the weight of what? Of the leg plus the cast. And they've told us to say that is 190 newtons, like that. Then they've also given us the weight of the left block. Weight of the left block. And they've given that one to be how much? Let me just check again. They've said it's 110, this one. 110 at 48 degrees. I mean at 48 degrees, yeah. So this is 110 newtons. So how are we going to approach this question? If you're a student who takes physics, the first thing that should come to your mind is draw a free body diagram. So how is your free body diagram going to be? Because free body diagrams are very vital in your knowledge in physics. Because the moment you draw a wrong free body diagram, the whole answer is going to be trash. So let's put up a free body diagram here. I have weight number, is it the left block there, and it's going over a pulley. Then we have W1 there. There we have W2, and we have the x-axis there. They've said this angle there is alpha, also this angle is 48 degrees, like that. We have a force here of 110 newtons, and these are the only forces that they've given us, plus which one? Plus the weight of the leg and the cast, which is 190 newtons. So where is the weight of the leg and cast going to be? It's going to be at the center of mass of that leg and cast. So I think this is the one that has been given. Or using your common sense, you can see by just looking at that diagram to say the center of mass of the leg and cast was the one which was directed down there. So that is going to be equal to what? That is going to be equal to your W1. Okay, so let's now, okay, before I go to the next page, let's now put those forces into their respective axes. Let's resolve the forces that are being applied on this system. So we have this side, we're going to have the component or the x component of our 110 newtons, which is directed at 48 degrees. 48 degrees. So since it is the one which is adjacent to the angle theta here, it is going to carry a cos. I already explained about that when I was solving the Taylor sheet. So we're going to have 110 cos 48 here, whilst the y component will now carry a sine. So we have 110 sine 48 there. Then we also have this other force, which is the weight 2, W2, which is also existing in both axes. So it is going to be in this axis, which is the x-axis, and this one, which is the x component rather, it is the one which is adjacent to it, to this alpha. So it is going to carry the cosine of the alpha. So I'm going to say W2 cos alpha there. Then I'll have another one here in the y-axis, which will be equal to W2 sine alpha, or sine alpha, like that. Okay, so those are the forces that we have. So in the y-axis, we have these two forces that are above here, and the W1 which is pointing down here. Whilst in the x-axis, we have these two forces which are opposite to each other. We have that one and that one there. So what are we going to do? Newton's laws of motion. We've already learned about that. So let's now let's now look at our forces in the respective axes. So for the forces in the x-axis, we're going to see that this one, which is pointing in the positive direction, will carry a positive sign. So we're going to say W2, since this object is already at equilibrium, that means there's no movement here. So which means the summation of these forces should be equal to 0. So W2 cos alpha will be equal to 110 cos 48 degrees, like that. Those are the forces that are in the x-axis. So we're going to say W2 cos alpha will be equal to the value of 110 cos 48, which is 73.6 newtons, like that. So that is an equation that we are going to have as our equation 1 in the x, because we can't go any further with this equation. We don't know W2 and we don't know the value of our alpha. Those are the things that we are trying to figure out in this question. Let's go to our forces which are in the x-axis, in the y-axis rather. So I have two forces which are pointing in the positive y direction. We have 110 sine 48 degrees and the W2 sine alpha. And the force which is in the negative direction is the W1. So what are we going to have? We have, let me change the color. Okay, so we have 110 sine 48 degrees plus W2 sine alpha. And these forces should be equal to what? Should be equal to W1, of which what is the value of W1? That is 190 newtons. So from there, we're going to find the value of 110 sine 48, which is given 81.7 plus W2 sine alpha. This should be equal to 190, like that. So what are we going to do here automatically by transferring this constant to the other side of the equation so that we remain with the W2 sine alpha. So I'll remain with W2 sine alpha on the left hand side, and this will be equal to what? It will be equal to 190 minus 81.7 there. And that difference is giving us 190 minus 81.7. That will give us 108. 108.3, like that. So now that we have these two expressions, we have this expression in the x and we have this expression in the y. What are we going to do? Let's divide these two expressions and see what we're going to remain with. So we're going to have W2 sine alpha over W2 cos alpha, and this will be equal to what? It will be equal to 108.3 over 73.6 or 78.6, not 73, sorry. This is okay, 73.6, like that. So if you've done trigonometry before, I'm sure you'll agree with me. W2 and W2 cancel out from that side. We have cos sine alpha divided by cos alpha. And this is going to give us what? It is going to give us a tan alpha. Tan alpha will be equal to the value of the answer we're going to find when we divide 108 over 73.6, of which I'll write it like this, just like this. There's no need to divide, but if you want, you can divide it. So we have tan alpha is equal to 108 over, or 108.3 over 73.6. So from here, what are we going to do? We're going to say alpha will be equal to the tan inverse of these guys which are here. 12 tan inverse of 108.3 over 73.6, like that. So when we find the tan inverse here, or the tan inverse of that value, that means we found the value of our alpha, of which that was one of the questions which were asked in the question. So we should find the value of alpha. So alpha will be equal to what? The value of alpha is going to be given as when you divide that this guy in the bracket in the brackets by tan inverse, you're going to get 55.8 degrees, and that is the value of our alpha. Now that we found the value of alpha, we can simply find W2 now, because in these two expressions that we found for both the x and the y axis, we involved W2. So I'll use the one in the x, which is saying W2 cos alpha is equal to 73.6 newtons. So if I use this one, what am I going to get? I'm going to get W2 cos alpha. Remember, we are from finding the value of alpha, and this is equal to 73.6. So W2 will be equal to 73.6 over cos 55.8. And from here, we're going to find the value of W2 to be equal to what? To be equal to 130.9 newtons. Okay, so that is all about question 2. We can move on to the next question. I mean question 2A rather. We can move on to the next question. Okay, so we have this question here which is saying a cat spots a mouse that is 7.53 meters away and immediately accelerates towards it. The mouse reacts to the cat after 0.4 seconds and dashes away from the cat. Both the cat and the mouse take 0.8 seconds to attain their maximum speeds. The graph shows how the speeds of both creatures vary with time. How far apart are the creatures? 6 point 6.8 seconds after the cat began running. So this question is very simple. There's nothing really complicated about this one. You just have a cat which is chasing a mouse. So the points we're supposed to really take note of is that the cat starts running first before the mouse started running. And also one very important point is that the cat was standing 7.53 meters away from the cat. So I mean away from the mouse. So which means the mouse was already in front of the cat by 7.53 meters. So how are we going to find the distance between these two animals after running 6.8 seconds after the cat had started running? They've already given us the diagrams here, the diagrams of motion, the velocity time graph for both these two animals. So we have the one for the cat, which is this one here, the bigger one, and we have one for the mouse, which is this one, the smaller one. So what are we going to do in order for us to find the distance? We're going to find the area under these two graphs, the graph for the cat and the graph for the mouse. So this area that we're going to find is going to tell us the distance that these animals moved 6.8 seconds after the cat had started running. When we find that distance now, we're going to subtract the two to see how much distance is between these two animals after 6.8 seconds. But remember, the mouse was already 7.53 meters in front of the cat. So we're going to add that 7.53 meters to the distance that the mouse is going to move. Then subtract the distance that is going to be moved by the cat. So that's not a very difficult thing. I'm sure we know how to find the area under the graphs. These are both trapeziums, and we know to say for you to find the area under a trapezium, you say half, open bracket, A plus B, close bracket, H, like that. So that is how you're finding your area under a trapezium. But let's take note. If we are saying A, let's say we are considering A as this distance which is on top here of our trapezium, and B this distance which is down here. What are we going to take note of? We're going to find that the one for the cat, A, is equal to what? A is equal to from this line here. So that line, this graph is already drawn to scale. So what is that line depicting? We have 0 here, 0.2, 0.3, 0.2, 0.4, 0.6, 0.8, 1. So if 1 is here, and we follow this graph up to there, you can see that, up to here, you can see that it's starting from 0.8. So when counting our A, we're going to start from 0.8 seconds. So which means from the 6.8 seconds where this graph is ending here, we're supposed to subtract 0.8 seconds, of which, so which means our A is equal to 6. Our B will be the distance from here up to that point, which will be equal to what? It will be equal to 6.8 itself. Then our height is just from here up to that point. And that is what? If we have 2 there, that means we have 2.1, 0.2, 0.3, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So we have 3.9 as our h. So this is B. Height is 3.9, like that. Then after finding that, let's now go to the mouse. Our mouse, how are we collecting the data? So you can see the mouse started running 0.4 seconds after the cat had started running. So which means my A, my B, and my height for the mouse will be equal to what? The B will be the distance from here, where the graph is starting, up to this point where my graph is ending. So let me just rub some things, reduce the date on the graph. Okay, so let me we're going to measure our B from there, where the graph is starting, to where it's ending. So which means from our B, we are subtracting 0.4 from 0.8. So which means our B is equal to what? It will be 6.4. What about our A? Our A is starting from here up to that point where the graph is ending. So we have 0.5, we have 0.2, 0.4, 0.6, 0.8, 1, 1.2. So it is starting from 1.2. So we're going to say 6.8 seconds minus 1.2, of which that is going to give us how much? As our A, it is going to give us 6.8, we subtract 1.2. This is 1.2, if I'm not mistaken. So that means we're going to have 5.6 as our A. What about our height? Our height is 2.1, 0.2, 0.3, 0.4, 0.5. So our height is 2.5. Okay, so this is the data that we're going to use on our formulas for the cut, or to find the distance covered by the cut and the distance covered by the mouse, respectively. So let's go to our blank board now. Don't know why the board is black. Oh, okay. So we're going to say question 3b here. We have your cut and we have our mouse here. So I'm going to say for the cut area, it's equal to half A plus B H. The same is applying to the mouse, like that. So we said the data that we have on the cut, we have A will be equal to half. What is our A? We said our A is equal to 6.0. 6.0 plus 6.8 multiplied by the height, of which the height, we said it's 2.9. Okay, even here it was 2.9 and not 3.9. Let's correct that mistake. I said 3.9 instead of 2.9. Okay, so 2.9 there, of which we are going to end up getting what? We're going to end up getting half, open brackets, 12.8, close 2.9. So if I plug this into my calculator, just the way it is, I'm going to get the area under the graph for the cut is equal to 18.56 meters. 0.56 meters. So what about the graph for the mouse? So I'm going to do the same. I'll say my A is equal to half. What was my A? My A was 5.6 plus my B, which was 6.4. My H was 2.5. Okay, like that. So I'll have A being equal to half. What is the sum of those guys inside? It's a 12 multiplied by 2.5. So the area under the graph, the area under the graph for the mouse is going to be equal to 15 meters. So which means from the time the cat started running up to when it was 6.8 seconds, the cat had traveled 18.56 meters, whilst the mouse only traveled 15 meters. So how are we going to find the distance between these two guys? We're supposed to subtract the two distances. But what did we say? Remember, the mouse was already 7.53 meters in front of the cat. So we're going to add that 7.53 meters to the distance traveled by the mouse. So I'll say plus 7.53 meters like that. So, which means if I want to find the distance now, I'll say my distance between the cat and the mouse will be equal to 15 plus 7.53 minus 18.56 meters like that. From there, I'm getting 22.53 minus 18.56. From there, I'm getting a distance which is equal to 3.97 meters. Okay, so that was the end of question 3B. And thank you very much, guys, for watching. Just make sure you like the video and subscribe to my channel for more content like this. Stay blessed.